Why are there no square animals?
Are you sure?
Not animals with square patterns. Not animals that look vaguely boxy from one very flattering camera angle. An actual square animal. Technically, a three-dimensional square is a cube. An actual square animal would be completely flat, which introduces several new problems that we are definitely not going to tackle today.
Are you sure?
So, picture a rabbit shaped like a footstool. 4 straight sides, flat top, crisp corners, 2 ears sticking out like somebody assembled it incorrectly. Or imagine a herd of cube-shaped deer moving through the forest. They would not so much run as appear to be furniture fleeing a house fire. Nature has produced animals shaped like ribbons, pancakes, umbrellas, needles, balloons, leaves, rocks, sticks, and things that look like someone sneezed into a jar.
Ew.
But almost nothing looks like it was built from a cardboard box. That seems strange, because squares are everywhere in the human world. Rooms are square, screens are rectangular, buildings are full of flat walls and right angles. So why does nature apparently refuse to put an animal in one? The obvious answer is that a box-shaped body would be terrible for moving. And that is partly true. But it is not the whole answer. Because there is an animal that came surprisingly close. But before we meet the swimming lunchbox, we need to work out why box-shaped bodies are so rare in the first place.
The first problem is that animals aren't constructed the way boxes are. A box begins as flat pieces. Someone cuts straight lines, measures angles, and joins the pieces along sharp edges. An animal begins as living cells. Those cells are roundish, divide, change shape, move, pull on one another, and produce materials around themselves. Layers of tissue bend. Some areas grow faster than others. Surfaces fold, stretch, and buckle. The body is not being carved toward a finished blueprint. It is growing from the inside while every part remains connected to every other part. And growth like that naturally produces curves. Think about inflating a balloon. You do not get 6 flat faces and 8 neat corners. Internal pressure pushes the surface outward, and the flexible material smooths itself into a rounded form. Animal bodies are obviously much more complicated than balloons, but they contain fluids, soft tissues, membranes, organs, and muscles under tension. Those materials do not casually hold perfect flat planes or sudden 90-degree turns. To keep a sharp corner, the body would need to build and maintain that corner on purpose. The cells on the flat face would have to grow differently from the cells along the edge. The edge would need enough stiffness to resist rounding. And all of this would have to remain coordinated while the animal grew from an embryo into an adult. That's not impossible. It's simply a lot of biological administration for a corner that may not do anything useful. And that brings us to the larger problem.
Evolution does not collect shapes. A body shape survives because it helps an animal do something. Move, feed, hide, stay warm, avoid overheating, protect itself, reproduce, or fit into a particular space. A perfect cube is a mathematical description, not a job. For most animals, a body with smooth transitions works better because different parts need to perform different tasks. A head has to meet a neck. A neck has to meet a torso. Limbs need joints. Muscles need places to attach and room to shorten. The abdomen may need to expand after a meal. The chest may need to change shape during breathing. A pregnant animal may need to temporarily become less committed to its original dimensions. A box offers 6 excellent walls and absolutely no opinion about where the shoulders should go. Movement makes the problem worse. Many swimming animals create thrust by bending their bodies. Running animals rotate joints and flex their spines. Burrowing animals squeeze through spaces. Flying animals constantly redistribute forces through wings, muscles, and the skeleton. A rigid block is not automatically incapable of moving, but it makes movement harder to organize. It places a large, stiff object in the middle of a system that often works by bending. Even the surface is a compromise. For the same amount of internal volume, a cube needs about 24% more surface area than a sphere. That means more skin and more area through which heat and water can be exchanged with the environment. Sometimes extra surface area is useful. Like in rabbits, they lose heat in summer through their ears. I know, weird, right? But notice what evolution usually does. It adds surface area where it helps. It doesn't turn the entire animal into a badly optimized box. There is also a structural problem. Abrupt changes in shape can concentrate stress. Engineers soften corners for the same reason. Aircraft windows are rounded. Openings in shells and frames are often curved. A gradual transition can spread forces more gently than a sudden geometric turn. Living structures use versions of the same trick. Bones widen into joints. Shells curve. Hard and soft tissues often blend through transition zones instead of meeting like two pieces of plywood. A whole body covered in crisp edges would need reinforcement exactly where those edges meet. More material, more weight, more maintenance. Again, none of this makes corners forbidden. Nature produces claws, horns, teeth, spines, armor plates, and remarkably geometric shells. But those shapes usually serve a purpose. The sharper or more rigid the structure, the better the reason tends to be.
Which means that if we want to find something close to a square animal, we should look for a creature with an unusually good reason to become stiff. Enter the boxfish. There is even a species called the yellow boxfish, whose scientific name is Ostracion cubicus. Cubicus! Biologists saw this fish and apparently decided subtlety was no longer necessary. Its body has a roughly square cross-section and is wrapped in a rigid carapace made from tightly joined bony plates. It is not merely a plump fish with an unfortunate profile. It is wearing a structural box. And the main benefit appears to be protection. The hard casing acts as armor against predators. Once armor becomes important enough, flat areas, ridges, and edges can become worthwhile because the body is no longer relying entirely on soft tissue to hold its shape. So nature can produce something close to a cube. It just has to build the cube out of bone. But becoming a box creates a rather serious fish problem. Most fish swim by bending their bodies from side to side. The boxfish can't do much of that because its torso is locked inside rigid armor. Its solution is to move mainly with its fins. In other words, it became box-shaped by outsourcing movement to the parts sticking out of the box. That is the trade-off. Protection increased, body flexibility disappeared. And for a long time, researchers assumed the boxy shell must also provide excellent hydrodynamic stability. The shape even inspired vehicle designs. But experiments and computer simulations complicated that story. The boxfish body is not an exceptionally low-drag masterpiece. In some directions, water flowing around the rigid shell can actually destabilize it. That sounds like a design failure. For the fish, it may be useful. A body that is slightly unstable can turn more easily, while the fins actively control it. Boxfish live around complicated habitats, such as coral reefs, where hovering and making tight turns can matter more than cruising efficiently across an open ocean. It is less like a train and more like a forklift. Not elegant at high speed, very useful near shelves. And even this champion of biological boxiness does not form a perfect cube. Its edges are rounded, its faces are not mathematically flat. The mouth, eyes, fins, and tail all interrupt the geometry. Different boxfish species have bodies that can be rectangular, triangular, pentagonal, or much more rounded in cross-section.
nature approached the box, then immediately began modifying it for the inconveniences caused by being a box.
That may be the real answer. There is no single law preventing a square animal. Instead, several pressures all lean away from it. Soft tissues tend to curve. Growing bodies are easier to shape through gradual changes than abrupt geometric boundaries. Movement usually rewards flexibility, tapering, or smooth transitions. Corners can require reinforcement. And a cube does not automatically solve any major biological problem better than the enormous collection of rounded, elongated, flattened, segmented, and irregular shapes already available. Evolution can only modify what a lineage already has, one workable change at a time. So an animal does not suddenly receive 6 flat sides because the final result might look interesting. Every slightly boxier ancestor along the way must still survive. The boxfish had a route. Armor became useful. Bony plates joined together. The body became rigid. The fins took over more of the locomotion. A box-like form emerged as part of a larger package of compromises. Most animals never encounter a reason to take that route. A fox does not need reinforced corners. A bird would gain very little from becoming airborne luggage. And a cube-shaped cheetah would solve the predator-prey relationship by making everyone equally confused. So why are there no truly square animals? Because being square is not a useful biological goal. Curves are easier for soft bodies to grow, easier for forces to travel through, and usually easier to move. Nature can build a box when armor makes the cost worthwhile, but even then it adds fins, rounds the corners, and refuses to use a ruler. The square animal is not impossible. It is simply a solution waiting for a problem that almost never exists.
Subscribe if you enjoy strange questions that become much larger investigations than they had any right to be. Then, if you have ever stepped outside and somehow known rain was coming before a single drop fell, watch our previous video. Because apparently, your nose may know more about the weather than the weatherman.